Hello family, these are our solutions for Can You Do 61. These solutions are probably going to be a lot shorter than they normally are. One, because this assignment isn't very long, but two, some of these assignments have questions that are very similar. For instance, number 9 is very similar to number 10. So what I'm going to do instead of giving you the answers to every problem is I'm going to do one of them, and then I'm going to have you do the other one without me, and I'm going to grade it. So because I won't be going through every single problem, some of the solutions videos in this unit will be a little bit shorter. Now, as usual, you're going to get the most out of this if you try these problems on your own first. So if you haven't tried these problems yet, I would strongly encourage you to actually give the problems a go and then come back here to check your answer. So number 9 is prayer in school. We want to interpret the confidence interval that was given to us. So we are 95% confident that the interval from 0.63 to 0.69 captures the population proportion who favor such an amendment. So I used this phrasing here for my context. Remember, context is really important to the AP board. They go through and ask you to find your point estimate and your margin of error. So I wish that I would have used symbols here, so I'll just add that in now. Your point estimate is p hat. So what happened is we took a sample and the sample proportion was 66%. 66% of the people we sampled said they would favor such an amendment. What is our margin of error? Well, we might be off by about 3%. So this is your standard error of p hat. So what that means is we are typically, or we might typically be off by about 3% from the true value. So our sample value is 66%, and that is our estimate for the true value. And then we think that it's possible that we might be off from the actual true value by about 3%. So essentially we're saying the true value could be anywhere between 63 and 69%. We got 66%, and we could be off by 3% on either end. Based on the poll, a reporter claims that more than 2/3 of adults favor such an amendment. Use your confidence interval to evaluate the claim. So the claim is that true P is bigger than 2/3, which is 0.67. So we look at our confidence interval and we see, is 0.67 in our confidence interval? And it is. In fact, 0.67 is, 0.68 is, and 0.69 is. So we do not have evidence against the claim. Now remember, in the lesson video, I was talking about how from here on out, we want to make sure that we're really careful to state our conclusion in terms of evidence against the claim or not having evidence against the claim. We don't ever want to say our confidence interval supports the claim. Our only purpose in using our confidence interval is to say whether or not there's evidence against. That's it. So we do not have evidence against the claim. That's different than saying we have evidence that supports the claim. So here's my response, and it follows very closely the response that's in your notes on page 608. So I'm following this almost like word for word, and then changing the context where the blanks are. Any value from 0.63 to 0.69 is a plausible value for the population proportion who favor such an amendment. Since 2/3 is a plausible value because it's in our confidence interval, our confidence interval does not give convincing evidence against the claim. So then, number 10, is basically the same problem. So you can see here that I have it done, but I've covered it up because I decided I wanted you to try some without me going through them. So I'm going to have you do 10 and 11 without me. So 10 and 11 I am going to grade, but I will do 12 with you because 12 is similar to 11. So 12 wants us to look at our confidence intervals that were created and state what confidence interval we think was used. So in this case, all of my intervals captured true mu. If I highlight my true mu, and it is already in green, but if I highlight that true mu, it goes through every single confidence interval. So that means 100% of my confidence intervals captured true mu. Well, we don't have 100% confidence interval. The closest to that is 99. So I'm saying all intervals captured mu, so I think a 99% confidence interval was used. Now, in our notes, we were able to use the exact level that was captured. So here, 24 out of the 25 captured true mu, so that's 96%. So I would conclude my confidence level is 96%. So typically, you use the percent that you get, the percent that actually captures true mu. The only reason here that I'm not using the exact percent is because 100 is not a possible confidence interval. So I'm using the one that is closest. So on this previous problem, if you ended up getting that 81% of them capture the mean, then you would say your confidence level is 81%. So you don't typically change the percent that you get. I'm only changing this one because our typical options for a confidence interval do not include 100%. Well, actually, I'm lying. So when I said here, if 81% captured it, you would use 81%. You wouldn't. You would use whatever confidence level is below it on our pink table. I'm just trying to locate the pink table. So here in our notes, 96% confidence is an option. Here, 100% is not an option. So we want to go the closest one below. So that would be 99%. I guess I could have used one of these. I guess I could have used a 99.9% confidence interval. So let's say on this problem, you get that it's 92%. Then you would say that's a 90% confidence interval. Let's say you get 86%. You would say that's an 80% confidence interval. So you round down to the closest confidence interval. You round down to the closest confidence interval. So just to maybe do one more, if I got 98% confidence, I would keep it because 98% confidence is on this table. I'm choosing 99 for the next one because I want to be on the safe side. I don't want to say 99.9. I think that's a little bit too close, so I'm going to go down 1 full percent and say 99% to be conservative. Sorry about that confusion. I realized right after I said it that we want to go the closest one on our pink table below. If this is confusing and you have any questions about this, email me or ask me in class and I can verify that your answer is right. So if you're unsure, email me what you think your answer is or tell me what you think your answer is in class and I will verify whether or not you're on the right track. Okay, number 21, I'm going to have you do on your own, but 22, I will talk about with you. So a researcher is deciding between a sample size of 500 or 1,000. Compared to a sample size of 500, a 95% confidence interval based on the sample size of 1,000 will be. So we're saying we constructed a confidence interval for a sample of 500. Now construct another confidence interval for a sample of 1,000. How would those two confidence intervals compare? So what I have here is what I know sample size does to the margin of error, because it's your margin of error that determines width. So your margin of error determines width. But remember, margin of error is your critical value multiplied by your standard error. This critical value stays the same because they're saying you're doing a 95% confidence interval either way. This standard error decreases if you increase n. So if you increase n, this decreases. If that decreases, that means that your confidence interval gets narrower because this decreases. So our options need to be narrower. So B and D are not an option. Then it says, does our risk change? Well, if I revisit how risk is determined, it looks like our confidence level is what determines risk. So notice here when we're talking about risk, we're looking at the confidence level. We're not looking at the standard error. We're looking at whether it's 99%, 95%, 90%. So I have here that the risk is the same because risk has to do with confidence level and that did not change. So narrower interval, same risk of being incorrect because your 95% confidence stays the same. I'm going to have you do 24, but 23 I would like to talk about because we just, we didn't talk about this too much in the lesson, especially 1A. We didn't get to this in 1A. We didn't get to talk about it for very long. So 23, there is some error that can be caused by or as a result of your sampling method. Just give me like 2 minutes. Okay, I'm almost done. I literally am almost done. I don't care. So some of the error that could be caused by our method of sampling are these things. So these things are things that we could control. So some people refuse to answer the question. Some people, without a telephone, you're doing a telephone survey and they don't have a phone, so you would not be able to get their input. And maybe some people just choose not to answer. These are all errors as a result of your sampling method. However, this margin of error here has to do with sampling variability. So you could have two types of errors happening with your confidence interval. One has to do with sampling variability, the fact that your samples will differ, so you have to account for that. And the other has to do with your sampling method. So this one says, which of these is a possible source of bias that is included in your margin of error for the poll? And the answer would be none. These all have to do with how you take your sample. This has to do with the natural occurrence of your samples being different. So when you say you have a 96% confidence level, that means that that missing 4% is a result of these things. That missing 4 comes from your sampling method. This 96% confidence takes into account sampling variability and includes your margin of error. So none of these are in your margin of error because that has to do with sampling variability. So all the ones that I didn't go over, I will grade for you and get back to you. If you have any questions, email me. Yeah, love you guys.